In a universe teeming with light, it's easy to assume that all stars want to be seen, that their purpose is to shine, to illuminate, to announce their presence across the void. But not all stars burn for our eyes. Some retreat into darkness long before their final breath. Some cloak themselves in silence. And so it was with one red supergiant, a star so massive, so swollen with its own aging fusion, that its demise was not only inevitable, it was imminent. But the universe kept it hidden, wrapped in layers of dust and time, veiled behind a curtain that not even the sharpest telescopes could pierce in visible light. It lived in the shadows, unseen, not because it was weak, but because it had grown old and weary. It no longer radiated like the young stars that twinkle in newborn nebulae. Its outer layers had been cast off again and again, forming dense clouds around it, a shroud made not by death, but by the long, slow process of dying. We had no idea it was there. No idea that something so colossal, hundreds of times the size of our sun, could vanish from our view entirely. But it had not vanished from the universe. It waited, quietly, for its final act. Every star has a beginning, but not all stars are granted the luxury of a slow and quiet end. Some are destined to collapse in fire, their deaths written into their very birth by the sheer weight of their mass. Red supergiants are these giants of fate. They are the swollen remnants of once stable, middle-aged stars, now nearing the limits of their nuclear engines. These stars have burned through their core hydrogen, then helium, and now struggle to sustain themselves by fusing heavier and heavier elements in a frantic bid to resist the pull of gravity. Imagine a star that has swollen to encompass the orbit of Mars, with an atmosphere so bloated and tenuous that a spacecraft could fly through it without even noticing. That is the red supergiant, massive, luminous, and fragile all at once. They are beautiful in their impermanence, and yet, despite their grandeur, they are unstable. Their cores are time bombs, accumulating iron, the element that signals the end. Iron cannot produce energy through fusion. It simply sits at the heart of the star like a stone, dragging the rest of the structure toward inevitable collapse. When the balance breaks, when gravity overwhelms pressure, the core implodes. In an instant, the outer layers follow, exploding outward in a supernova so luminous that it can be seen across entire galaxies. But the warning signs, the subtle shifts, the final breaths, have always eluded us. Until now. The galaxy NGC 772, nearly 130 million light-years away, is not unfamiliar to astronomers. It's a spiral galaxy, graceful and bright, often the subject of astrophotography and research alike. But nestled deep within it, in a spiral arm awash with starlight, something changed. It was subtle, a whisper in the data, an object that didn't belong, faint, warm, but not visible to the eye. It wasn't a typical star, nor a distant galaxy. It pulsed gently in the infrared, a red supergiant, cloaked in dust, shedding its final layers into the cold. Then, just days later, that faint infrared signature disappeared, replaced by a sudden burst of brilliance. A supernova, the detonation of a star, the birth of a cosmic ghost. But unlike every other time before, we had seen what came just before. We had the before photo, the glimpse behind the veil. For the first time in astronomical history, we didn't have to guess what the progenitor looked like. We didn't have to rely on distant archives or reconstruct events after the fact. We had seen a dying star in the days before death, and that changed everything. Dying stars don't go quietly, but they often die in hiding. In their final years, red supergiants undergo violent internal shifts, throwing off their outer layers in slow-motion detonations. These ejections aren't explosions, but they are violent in their own way. Massive waves of gas pushed into space by pressure, radiation, and time. This material forms thick clouds, shells, and plumes that wrap around the star like gauze. These veils block visible light. To our telescopes, the star fades into nothingness. But in the infrared spectrum, where heat and longer wavelengths reign, that same dust glows. Infrared astronomy sees what our eyes cannot, the warm breath of dying stars. And it was through this invisible window that we glimpsed the hidden red supergiant, glowing faintly beneath the dust like an ember hidden in ash. Not burning brightly, not calling attention to itself, just existing, waiting, preparing. How many other stars are doing the same thing right now? How many other giants are whispering in the dark, unknown to us, quietly building toward one final collapse? In the final days of its life, the star trembled. Subtle pulses of energy flickered through its outer layers. Not visible to our eyes, not even dramatic enough to change its infrared brightness in ways we might immediately notice. But something was happening. Perhaps it was the silicon flash, a final surge of fusion deep inside, trying desperately to resist collapse. Perhaps it was convection run wild, hot bubbles of plasma roaring through the star's atmosphere, pushing material outward in waves. Perhaps it was nothing more than gravity beginning to win. Then silence, a final moment of stability before the storm, a deceptive calm, the eye before the implosion, and then the collapse. The core gave in, the outer layers followed. A rebounding shockwave surged outward from the compressed, dying heart. In a fraction of a second, a star became a supernova, its light, heat, and fury erupting into the interstellar medium. The veil of dust that had hidden it for so long was swept away by fire. And the universe, finally, saw what had been hiding beneath. This observation didn't just give us a clearer view of a dying star. It forced us to rewrite the very story we thought we knew. Before this, we assumed red supergiants nearing death would brighten in visible light, maybe pulse irregularly or eject obvious material. But many might not. Many might dim instead, hide, choke on their own dust. The dusty death, once thought to be rare, might actually be common. Have we been blind to dozens, maybe hundreds, of dying stars simply because we were looking in the wrong spectrum? If so, what else have we missed? What nuances in pre-supernova activity? What last signs of instability? This one star, invisible until the very end, has opened a door we didn't know existed. And we are now only just beginning to walk through it. We now stand at the edge of a new era in stellar astronomy, one where we no longer wait for stars to explode, but instead watch them in anticipation. Infrared space telescopes, like the James Webb, are already monitoring regions where red supergiants live, searching for that telltale flicker. Soon, wide-field infrared surveys will scan entire galaxies regularly, hunting for dying giants hiding behind their own veils. Machine learning will play a role, too. Algorithms trained to detect subtle patterns in a star's final light curve, trained not just to recognize the obvious, but to listen for the softest whispers of collapse. And when the next hidden star begins to stir, when its veil glows just a little brighter in infrared, we may be watching, waiting, and this time we'll be ready. The star is gone now. What remains is a remnant, perhaps a neutron star, pulsing with the rhythm of a collapsed core, or perhaps a black hole, silent and still. But its legacy endures, not in the explosion, as grand as it was, but in the quiet moment before, in the veil it wore, and in the message that veil delivered. It taught us that death is not always loud, that endings are not always visible, that some truths in the universe are hidden not because they are small, but because they are wrapped in the very dust of their making. We saw a star die, and in doing so, we learned how to see death differently, not as an ending, but as a revelation. In the dark, something flickered, a light that wasn't meant to be seen, a final breath caught in silence. And for the first time, we listened.